We are live in the flesh here with Dr. Tim Jackson. Dr. Tim, so happy we could make this work. Again, Dr. Tim is a physician. You're in Georgia, right? Dr.
I'm in
Tim?
Georgia, Roswell,
Yeah.
Georgia.
Love it. And your website is healyourbody.org, correct?
Correct, exactly.
You got a new website coming soon. So love it. Dr. Tim, welcome back to the podcast. This is your third time on the show. We got you in the flesh. So let's dig in first. Let's do a quick little breakdown. MTHFR, give us the breakdown. What is it? Kind of why does it matter? And what do people need to do if they have it?
Yeah, so it's the enzyme that helps convert folic acid or folinic acid into methylfolate, which is vitamin B9. And the reason that's so important is methylation isn't just one reaction. It's several hundred to several thousand different reactions depending on what's going on in the cell. And so methylation, the process as a whole, requires not just methylfolate, but B12, all the other B vitamins, magnesium, zinc, and some other select minerals.
You also need healthy gut function too. So a lot of people just think, okay, I'm just going to avoid folic acid and take a methylated folate and I'm good, right? But also the gut function plays into it too, right?
Yeah, and that's where people, a lot of times they think that I'm not going to work on, methylation or epigenetics because I don't start there. But, you made a greght point. And then the other thing is if you have a lot of bacterial infections in the gut, the lipopolysaccharides and the endotoxins overload phase 1 and phase 2 in the liver. And so, the first thing you want to do is relieve as much stress as you can on the liver. And that right there is going to help to improve methylation and all the different reactions, acetylation, glucuronidation, sulfation that are in phase 2 in the liver.
Yes.
So just to kind of summarize the whole process as a whole, methylation is responsible for creating some of your immune cells called CD4 and CD8.
Yep.
Helper T cells and suppressor T cells. Glutathione, which is very important for detox, but it's also an important antiviral and helps control the redox status of the cell.
Correct.
It's responsible for neurotransmitter production, serotonin and dopamine. It's also responsible for different growth factors that deliver and process nutrients to the cells. And also it plays a significant role in controlling inflammation and viral replication or viral expression. So normally we want any viruses we have in our body or in our DNA to be methylated so that they don't express their genes. And if we're not methylating well, those viruses can become active.
Got it. And so methylation, how does it activate our genome? Because we have all methyl donor is a carbon and 3 hydrogens.
Right.
So it basically attaches itself to various parts of the genome, and it has major effects at activating various genetic expression. So what's happening there? Like what's happening at that genetic level? Is that methyl group literally binding to each part of the genome? What's going on there?
Yeah, so I mean, you can methylate neurotransmitters, you can methylate hormones. For example,
that's just that carbon and 3 hydrogen binding or interacting with that biochemical reaction, right?
Exactly. And so, it's important for so many different systems in the body. Pretty much every system in the body is impacted by methylation, either directly or indirectly. And you have on your DNA or in our nuclear DNA what are called CPG islands, which are just, it's a portion of your DNA where the methyl group binds. And you have to move around, our nuclear DNA is protected by histones, which are these proteins that help to keep it folded up. And there are some things that you want to methylate and some things that you don't want methylated. For example, you want your cancer genes methylated so they don't express. If they do express, that's obviously not a good thing. But in terms of adding a methyl group, a carbon and 3 hydrogen atoms, that can be done to our neurotransmitters to move them along the metabolic pathways that they're on. Also the Krebs cycle, ATP, and recycling back to ADP. And then the production of, glutathione is so important That plays a role, and it's affected by other polymorphisms, which MTHFR is a polymorphism. It's not a mutation. So just to kind of touch on that, trisomy 21 or Down syndrome, that would be a mutation. MTHFR is what we call a single nucleotide polymorphism. So when we talk about DNA, it has an alphabet, A, T, C, and G. And those are the 4 letters. Normally A binds to T, C binds to G. But if you get a spelling error or a glitch, it can cause some hiccups in your biochemistry. And just because you have a polymorphism doesn't mean it's expressing. So, sometimes I'll get patients and their first page may be mostly red, but they may be feeling great and they're doing really well because the information that you feed your genes, including how you think, how you sleep, how you eat, how you exercise, are you breathing in mycotoxins? Are you getting enough sunlight? That determines whether the polymorphisms are expressed or not.
Exactly. So with MTHFR, we have the A1, A binds to T. That's the A1298C, I think.
Mm-hmm.
And then we can be heterozygous or homozygous. Homozygous means we have both copies of that SNP. Heterozygous means we only have one. So it's a plus and a minus. And then we have the C1, the C binds to G, right? The C677T, I think, and that binds to the G, right?
Right. Yeah. Right. So typically, there's several other forms.
And then one last, I want to just stack onto this. So if we have only one of the C ones, if we're heterozygous, we only have one of those SNPs for the C, it's like a 30% reduction in our ability to activate and convert folate. And then if we have both, it's like 50%. And then if we are homozygous on both the C and the A, what is it, a 70 or 80% reduction in that?
Yeah, and it depends on which, I know you're referring to MTHFR, but it depends on which SNP you're talking about. And this is probably a good time to bring it up. Sometimes when you see a plus sign, that means that there's a down regulation of that enzyme. And that's what we're referring to with methylation.
Yes.
The enzyme and its reactions are slowing down. But there are some polymorphisms where when you see a plus sign, it means that the reactions have sped up. And so that's an important distinction, an upregulation versus a downregulation.
Interesting. And then if we're homozygous on both the C and the A, what percent reduction in that activation of that enzyme is there?
If you're homozygous for A1298C
and the C677T.
Oh, and the C677T. I've seen different statistics from 70 all the way to high 80s. The other thing that people don't realize is that you can have, let's say you're negative for all the MTHFR markers. You can have what I call a functional polymorphism, where if you have a lot of oxidative stress, a lot of heavy metals, those can block or slow down those pathways as well. So, you got to consider the redox status or the oxidative stress in the cell, nutrient availability, mineral status, all of those things factor in.
How do you evaluate a functional deficiency again? If there's no genomes that are positive there, if there are no positive SNPs?
So there's a test that measures SAM to SAL ratios, which are just two metabolites of the methylation pathway.
That's acetyl methionine versus acetyl homocysteine, right?
Correct. Yep. And Doctors Data does that.
Yep.
There's a more in-depth one from a company called Health Diagnostics Research Institute, but they're in Europe, so it takes a little bit longer. And so that's kind of looking at real time, the food you're eating, the supplements you're taking, the life you're living, how well you're methylating. And actually on the Dutch test now, they have like a little gas gauge.
Love that.
Yeah, because, like I was saying earlier, you have to methylate your hormones, especially your estrogens, in order to be able to get rid of them. And so we can get a look at, how well you're methylating. And, I tell people when we first start out, you may need to take methylfolate every day. And then over time, and depending on how many stressors you're accruing in your body at that moment or dealing with, you might be able to go down to 3 times a week or even 2 times a week. So, the same sort of principle when supplementing with something like magnesium that everyone's deficient in. I typically have people take it both orally and topically for the first 2 months and then go down to just orally.
It's great. So I want to get your take on it because I see a lot of MTHFR stuff. And I think it's kind of overrated. And I know we've talked about this before because just by working on someone's gut, you can help methylation, right? So we talked about that where people are there's like 3, I call them rabbit holes in functional medicine. One is Lyme, one is mold and mycotoxins, and the other is MTHFR. And not that they aren't real, they are important issues, but they mimic so many other issues where you could have a gut infection and adrenal dysfunction and low thyroid, and it can look like a Lyme co-infection, or it can look like an MTHFR issue or a mold issue. And the question is, are you treating it just because there's so many symptoms that correlate with it, or have you done your due diligence over all the other functional medicine hierarchy and worked your way down? So now, having said that, if someone's not eating, a whole bunch of bread and a whole bunch of refined orange juice that has got a whole bunch of added folic acid in it, and they're getting their leafy greens, maybe some liver, maybe some good quality meats, where does the MTHFR hurt you there? If you're pulling out a lot of the synthetic folic acid, that's where the MTHFR can really mess you up because of that folate you're getting is just crappy folic acid, and you can't make that conversion.
Right. That unmetabolized folic acid, Metametrics actually has a test for it because it lowers your natural killer cell level.
Exactly.
So,
any comments on what I just said, though?
Oh, yeah.
If we're not consuming that folic acid, that's a huge part of this, right? Because that's where a lot of these dangerous metabolites can happen.
Yeah. So part of it is also, leafy greens, supplies a lot of methylated folate or activated folate and not synthetic folic acid. If you're eating, General Mills, corn pops or Fruity Pebbles in the morning, then, you're getting a lot of folic acid. And I used to have an office right across from an OBGYN. And I said, I'll come in and do a lecture to your patients on, why this is so important in terms of conception and viable pregnancy. And she said, oh, I already treat MTHFR. I give them folic acid.
Right.
And I'm like, that's the opposite of what you want to do. But I deal with a lot of Lyme and mold, and I tend to kind of see it from the other end. I do see the adrenal dysfunction, the thyroid dysfunction. And, obviously when your body temperature is low, you're going to have a lot of chronic infections. And so I tell people, whether I'm working with a pro athlete or a kid with autism, not only does the gut have to be optimal, but the adrenals and the thyroid, because if those aren't functioning, it's going to slow down every enzymatic reaction in the body. And you got to tackle those before you start addressing sex hormones. And, in terms of Lyme and mold, it's really the chronic inflammatory cascade that comes after it that hacks into your neuroendocrine immune super system. So it can affect your neurotransmitters, your hormones. And when, us guys, when we have too much inflammation, too much of our testosterone converts to estrogen. Women, too much of their estrogen converts to testosterone. So it's all tangled in there. But what I see a lot of times is people, they try to kill an infection over and over and over and over. And one of my mentors told me, you can't kill your way to health, and what he meant by that was, not only do you need to change the terrain, but you need to, optimize body temperature, adrenal function, because a lot of people that are going to quote unquote naturopaths and, just they're getting put on a bunch of adaptogens, but there's no further investigation as to what's causing the HPA TGG dysfunction.
Right. And that's where I really appreciate your perspective, because when we're talking about MTHFR, you're looking upstream as well. You're looking at the gut function. It's not just, hey, let's give you some folate or even, some methylated B12. Let's go look at all the gut issues. And again, if we start giving nutrients, right, there's kind of a sequence, right? We talked about giving choline, giving other kind of methylated B vitamins alongside of it. Mm-hmm. And there's an order sometimes. Can you talk about methyl trapping a little bit as well and how that relates to MTHFR?
Yeah, so methyl trapping is basically, so you've probably heard, or your audience has probably heard of undermethylation, meaning you're not putting enough methyl groups on hormones, neurotransmitters, and other substrates. Or you can be over-methylating, where you're putting too many methyl groups. And just to kind of generalize, people who are over methylators, they tend to be kind of anxious, have pretty bad anxiety, trouble sleeping. If they get stressed out, it takes them a long time to come out of that funk. And so the under and over methylation can have to do, or is connected to, the methyl trapping. And as you mentioned, in terms of on the order of doing things, the B12 and the methylfolate are actually the last nutrients you want someone to start, because if you have a significant amount of oxidative stress and you add B12 and methylfolate, you create peroxynitrite, which is the second most common, or the second strongest free radical in the body. And so, I start by replenishing magnesium, zinc, selenium, iodine, all the minerals, really.
So like a really good kind of like a multivitamin kind of support. And then you kind of add in like a B- where it's everything but the B12 and folate to start.
Yeah, so that's what I typically do. And I generally don't give multi-minerals just because, so many people are so deficient in magnesium that I have to keep up in the levels for a while.
Higher, right?
Yeah, and then if some people have pyroluria, they may need extra manganese or zinc, or B6, or GLA. But you're right. Yeah, you want to add in a supplement like B-. And again, you're kind of prepping the pathways, because most people, they kind of think, oh, B vitamins, I can't possibly hurt myself. But you got to think of it like a jammed up, freeway that's been closed for 2 days, and now it's open and cars are all over the place. And so suddenly when the nutrients, when you have these nutrients that you need for these reactions to occur, your body turns on reactions that have been turned on for a long time. And so, you want to try and go slowly, because sometimes people will, there's usually 3 types of people. They'll start feeling good and they'll stay feeling good. They're kind of the, I think, rarest in my opinion. They start off feeling good and have a honeymoon period, and then they crash. And then the third group, they start off feeling poorly, and then, they stay feeling poorly because things were done in the wrong order, or they may just be so toxic. I mean, if someone's having 2 bowel movements a week and you're flooding them with methyl donors, trying to detox, you're essentially just retoxifying and redistributing things throughout the body.
So to avoid a lot of that methyl trapping, we'll do some of the mineral and vitamin stuff first. We'll do the B- vitamins, which is everything but the folate, and B12 second. And then do you prefer going folate third or B12 third?
B12, and along with the B12, typically I have
adenosyl hydroxyl kind of ones.
Yeah. So, but along with that, lithium orotate, because it helps transport B12 into the cell. But B12, depending on what someone's issues are, adenosyl is more going to help the mitochondria. Hydroxy is more going to help nitric oxide and blood vessel health. And then methyl B12, depending on what their tolerance is for methyl donors. So, we'll talk about COMT here in a minute, but, if you add too many methyl donors, like for example, a prescription methylfolate is Deplin, and it starts in really high doses. So you can put someone in a manic state or psychotic state if you go from 0 to 7.5 milligrams of methylfolate. And so, like you said, really improving gut health. Most people don't make that connection necessarily, but that's really where you want to start in terms of addressing methylfolate. And then, if someone's really sensitive when they do start methylfolate, I'll have them take it maybe every other day or every third day.
And do you like it in liquid form so you can titrate it up slower?
You can do it in liquid form. I also use in transdermal form.
Okay.
So it's actually in Austin, Texas, but Neurobiologics. So they have it's called Neuroimmune Stabilizer, and it has a higher dose of methylfolate along with B6 and B12. And a reason for that is, a lot of kids on the autism spectrum have methylation issues, and it's one less thing for them to swallow. So, using the topical cream is one way. And then the B12, even you can overmethylate someone just with too much methyl B12. And so, you always want to, if you're going to start that or do a trial period of it, start in very low doses and not, with the shots at really high doses.
And that's why you want your gut to be working better, because if you overmethylate and start dumping a whole bunch of stuff, if you don't have good detoxification system and good gut function, you can reabsorb a lot of that stuff, right?
Right, absolutely. Yeah, you can retoxify. And, just to talk about heavy metals briefly, if there's not inflammation in the GI tract, metals should come out through your phase 3 transporters. But when you
say phase 3 transporters, what are those exactly? Because most people that talk about detox, they kind of summarize it in phase 1, phase 2, right? Fat soluble, the water soluble out. What's phase 3?
Phase 3 is transport out of the body. So
it's part of phase 2 almost. It's similar.
Kind of. Yeah, this is more in the actual gut lining. And, it's going to bind the metals and help escort them out. But, Chris Shade talks about this a lot. When there's inflammation or malabsorption or assimilation problems in the gut, that shuts down phase 3. And, it puts extra stress on phase 2 and adds some of the stress to the kidneys. And so that's why it's so important. We talk about gut health and it being important, but no one talks very much about phase 3. And, just to give you a personal anecdote, about 11 or 12 years ago, I had IV chelation, and I had 15 or 16 treatments. It didn't budge my metals because my gut was inflamed and my methylation pathways weren't working. So, a lot of people will, throw you on IV this or IV that without really knowing, the downstream or upstream consequences.
Yeah, so the GI tract's really important with phase 3. That's good. That's why I'm always a big fan of, I always go through, my 3 body systems. System 1 is the hormone system. 2 is digestion and infections. I always do phase 2, body system 2 first before we go to body system 3, which is detox and nutrients. And a lot of it's built in for that reason, because if the gut's working better, then that phase 3 will work a lot better too, right?
Oh, absolutely. Yeah. And I mean, you want to calm down inflammation, regardless in the gut, but that's just giving you one more reason to do it.
We may see that by just getting rid of infections and also seeing improvements in IgA levels and also calprotectin.
You're right.
Correct?
Exactly.
That's great. Now let's go back to methyl trapping. So we're doing kind of the protocol in that order, B12 third, and we probably will use like a hydroxyl adenylyl B12, right? Adenylyl mitochondria, hydroxy for nitric oxide. And we're doing that in that order to prevent kind of the highway from getting crowded with cars, so to speak, right? And then we do the folate and maybe some of the methylated B12 fourth. Is that the case?
So what I'll do is I'll have typically people do either adenylyl and a really small amount of methyl, or adenylyl and hydroxy B12. And then, I'll give it, say, 5 to 7 days, and then have them slowly titrate in or layer in the methylfolate. And, once that dose is kind of stabilized, because I try to keep all the other variables constant, then we'll add in some B12, methyl B12 at a small dose to see how they tolerate it. A lot of times people will look at their COMT polymorphism and they'll say, oh, I'm homozygous, have 2 copies for this, can't take methyl B12. But really, it's more of just a trial and error, again, because you don't...
There where it talks about the methylation, and you connect it to a lot of the neurotransmitters, the dopamine, the serotonin. I want to get your take on that.
Yeah, so you can be dopamine insufficient, and Kendall Stewart, that I did some training with in Austin, he put together 7 different neurosensory tests. One is the impact, coming back from a concussion, eye tracking, ENG, and then testing the 8th cranial nerve, because he found, through connecting the dots in the research, that certain patterns on a hearing test will indicate both dopamine insufficiency and a viral infection.
Got it.
And so the dopamine is extremely important. And I don't want to go too far off track, but there's actually a condition called cerebral folate deficiency, where you can have normal levels of the methylated B vitamins in the bloodstream, but they may not be getting into the cerebral spinal fluid and affecting your neurological health like they should be. And that can be caused by antibodies to beta casein, in dairy. And in those cases, you typically have to use high doses to flood and upregulate the transporters. And sometimes the antibodies will go away, sometimes they won't. I was at a conference last weekend, and there's several labs now testing for the antibodies, because if you have that, that's super important. And in terms of the neurotransmitters, this is a whole other lecture, but a lot of times low neurotransmitters precede low hormone levels.
Got it. Amazing. So I'm pulling a couple things up here now so we can chat about it here. So I have our methylation map. I'm going to open up this image now so we can chat about it. And I'm going to shoot it over in your Skype window as well so you can take a peek at it, if that helps.
Okay. Let's see.
This is maybe a little bit fuzzy. I'll put it in your Skype window here so you can see it. Pull that up there. I'll grab another one here. And then, folks, we're live, right? So we are just, this is real. We're just going at it, and we're adapting to the environment, trying to bring some extra great information here. So Dr. Tim, pull that PDF. I'm going to pull up a methylation cycle chart here, and then we'll kind of comment on it and break it down for some of the listeners, make sense of it all.
Okay.
All right, here's a good one right here. I just want one that I can zoom in pretty well on.
Yeah, sorry. I'm just having a little trouble with my Skype. It's on my end. I don't know what's going on. But if you tell me which diagram we're looking at.
Yeah, I'm going to send you one right now here. I'm going to send you this one.
Well, that's the thing. Sorry, guys, but when I try to bring up my Skype, it's frozen. Wait. Okay, now there you go.
Yeah, just do the one in purple here. This purple one I like. It's really nice. I can kind of zoom in on it a little bit better. All right, I got it up on screen here.
Okay. Yeah, I thought I worked out all these kinks. Hold on 1 second.
I'm going to just download this one here so we got it.
Okay.
Okay, here it is on my screen. So I'll just keep
there we go.
here.
Okay, yes, yeah.
Yeah, so check your Skype. It'll be right in your Skype chat window. It's also in the chat window on your Google Chat. But there's a couple of these things here, right? They highlight decreased methylation, increased ammonia, elevated homocysteine. These are all kind of byproducts of what may happen in the methylation pathway. Can you just kind of go through here and just kind of break down just the key most important ones? There's so many overfactoids here. I don't want to overwhelm people. I just want them to get kind of what's the big take home? What should they be looking at in this methylation cycle?
Yeah, a couple things. That BH4 is probably one of the most important molecules they've never heard of. It's tetrahydrobiopterin, and it is the precursor to all of your neurotransmitters.
That's right here, this BH4 one right here.
Right, exactly.
Great.
And so, BH4, you can get it in supplement form, but it's usually not enough to reach a therapeutic level. So you can actually have it compounded. I have a colleague of mine, for my patients, see them and call in the prescription. But the BH4 is important for neurotransmitter health, detoxification, and just overall neurological health. And that can be depleted by things like ammonia. It says increased ammonia. Ammonia is going to, not only make your urine smell, but it can interfere with the urea cycle. And you can see there, the homocysteine goes to cystathionine, which goes to cysteine and ammonia. And from there, you can make glutathione and taurine. Glutathione obviously being incredibly important. As your levels of glutathione decline, your risk of every disease known to man actually increases. So that's extremely important. The elevated homocysteine, this is important for everyone to take note of this. So typically the C677T, MTHFR, C677T, everyone, kind of thinks of elevated homocysteine, and it can cause that. And that puts you at increased risk of heart attack, stroke, and in women, decreased bone density. But you can have perfectly normal homocysteine, which one of my mentors says between 7 and 9 is normal. Or you can actually have low homocysteine, where it's down around 3 or 4. And so if homocysteine is high, you definitely have a methylation issue. But if it's normal or low, you can still have a methylation issue. A lot of times, and I don't want to go too deep into it, but when homocysteine is really low, it's going down, and I don't think it's on this pathway, the CBS pathway, and the CBS drain, as they call it.
Right here.
But
yes.
Yeah, there we go, right there. And so, that's important because sometimes, and there's a good paper on it written by, I think, Dr. Lord from Metametrics.
Yeah, Dr. Jeffrey Lords. Yep.
Yeah, from importance of low homocysteine. Dr. Stewart keeps a ton of data, and he said that, just correlationally, his sickest patients have the lowest homocysteine.
Got it. So let's just kind of break this down, right? We talked about MTHFR. So MTHFR is affecting over here. This is the metabolism of folic acid, or if we're not consuming folic acid, folate or calcium folate into ultimately LMTHF, right? L-methyl tetrahydrofolate. And the enzyme that's involved in that is the methyl tetrahydrofolate reductase, correct? And this kind of ratchets this around. And then what's happening as we ratchet this around? What's happening here in this process?
So you're adding and taking away methyl groups. So you probably earlier, we talked about folic acid, and then I briefly mentioned folinic. So folinic acid is one step more active than folic, but one step lower than L5 methyl tetrahydrofolate. So I mentioned high dose folinic acid being used for cerebral folate deficiency, and that's prescription leucovorin. But you can also do it supplement wise. From the researchers I've talked to, and I don't know the exact reason, I don't think they know either, that folinic acid has some neurological benefits above and beyond what L5 methyl tetrahydrofolate does. And I asked that question because that's what they use in the studies in people with cerebral folate deficiency. But basically, you're adding methyl groups, you're taking away methyl groups, you're moving them around. But with that BH4, if it's low, pretty much all your neurotransmitters are going to be off. And that can affect mood, sleep, cognition, everything. And so with MTHFR, the A1298C, you can see elevated homocysteine, but you typically don't. That one is kind of more associated with what we call neuroimmune syndromes. So disorders like Alzheimer's, Parkinson's, MS, autism, lupus, etc., fall under that category.
Interesting.
And then with the ammonia, that is important because it drains your BH4. So elevated ammonia will deplete your BH4, and it can also deplete nitric oxide in some instances.
Interesting. So and again, if you're listening to this on the podcast, guys, make sure you check out the video because we have pictures up here and Dr. Tim's kind of breaking it down. So we're trying to nerd out because a lot of people talk about this stuff, and on a podcast, it's so hard to break these things down without some kind of a diagram or an image or a framework. So this is really helpful on the podcast side. So we have MTR, right? We know B12 is really important with MTR. What's MTR doing that MTHFR isn't?
MTR and MTRR have to do with processing B12. And typically, if you're heterozygous or homozygous, you're going to require extra B12. And one thing that's important to note is, everyone checks serum B12, or traditional medical doctors do. But as we both know, high in the blood, low in the cell. And that's where lithium transport comes in. If you look at some of the Asian countries and their reference ranges for B12, they're much higher, and there's been no documented adverse events to B12. But there are studies showing the higher your B12 levels, the slower your brain ages and the slower it shrinks. And so with MTR and MTRR, again, that gets back to the gut as well, with intrinsic factor, et cetera. but also you may need B12 shots. You can do them sublingually for a while. You can do it topically. You can do it, nebulize it. There's so many different ways. But B12, is extremely important. And, the MTR and MTRR are processing that B12. And so that, is where you look to see, okay, this person, let's check their methylmalonic acid and see if it's high and see if, they need extra B12.
Love it. Very good. And then if we keep on going down, we talked about the S-adenyl methionine up here and the S-adenyl homocysteine. So of course, this all comes from sulfur amino acids, methionine, and we know we need B6, we need folate here to prevent this from going down the homocysteine pathway right down here. So we need all those nutrients to allow this wheel to keep on turning. Is that correct?
That's correct. And if you look at this little portion of the diagram here where it says DNA, RNA, protein, and lipids, think about how important that is. You're methylating your DNA and your RNA. So you're literally affecting gene expression. And of course, methylating protein and lipids is important as well. But, we're talking about building nucleotides here, the very backbone of our DNA. So that's extremely important. And in terms of, you see the VDR in here, which is vitamin D receptor polymorphisms. And I don't want to get too far off track, but a lot of pathogens can affect in a negative way the vitamin D receptor, and it prevents the vitamin D from turning on some of the immune cells like the T regulatory cells that it should. And so, there's a whole protocol where they have you avoid vitamin D, which I don't believe in. But the point being that these pathogens are really smart and they can really manipulate our biochemistry. And so we have to really sit down and say, how can we bypass this?
Yeah, and you can see like a big imbalance between 25-hydroxy and 125-hydroxy, right?
Exactly.
125 is way skewed, right?
Thank you for saying that. Yes, you're the only doctor I've talked to who gets that. And the other thing is, even if you move your 25-hydroxy and it increases, you're not sulfating it if you're not getting enough vitamin D. And if you're a hyperconverter, you might be creating more inflammation. And if your RBC magnesium is low, you might be further excreting that through the urine. So you really have to, think through these things and not just throw, the latest supplement at it and hope it works.
So we may have to work on getting rid of that infection. What do you also think about using things like Japanese knotweed or resveratrol to help with that balance?
For the infections?
Well, for the 25 to 125 imbalance, I've seen some research that the Japanese
there's so many things. I'm all about nutrients like curcumin and resveratrol that affect many different pathways.
Yeah, a lot of those NRF2 pathways, right? Right,
exactly. So yeah, I think the resveratrol is very good. And then I'm not sure how to pronounce the activated form as for resveratrol, the PT. You know what I'm talking about?
Yeah, I know what you're talking about. Yeah,
I have no idea how to pronounce it, but that's supposed to work really well. And then what was the other nutrient you asked me about?
So let me just switch gears a little bit here too. So we're kind of here, right? We talked about homocysteine and these methylating nutrients. We went down here into the cysteine and the glutathione. We talked about how all-cause mortality increases with low glutathione. Let's switch gears and talk about the catecholamine methyltransferase and how this connects with dopamine and our neurotransmitters. Let's chat about that too.
Yeah, let's chat about not only that, but also how COMT affects estrogen levels.
Absolutely.
So with the COMT, and I'm a little bit biased because I have it, but there's a trade-off. Nature is smarter, way smarter than we are. And, if you have 1 or 2 copies of this SNP, there was a trade-off. You got it for a reason at some point in time. And they found that people with COMT in general have higher IQs, that's statistically significant. But the trade-off for that is if you cut me off in traffic, I'm going to probably throw my cup of coffee out the window at you, and I'll be pissed off all day. And then, it'll take me forever to, not be ticked off. But with the COMT, there's several different versions of it. And earlier we mentioned that, there's one, I think it's the V158, that's a down regulation, or excuse me, an upregulation of the COMT pathway, whereas the others are down regulation. And so what that means is your epinephrine, your norepinephrine, your dopamine, they don't get broken down like they should. And so you can kind of stay in that fight or flight or sympathetic dominant state. And with the COMT, that gets to the other point where you asked about, should you start with methyl B12? Should you not? So, if you're homozygous, 2 copies of COMT of several different forms of it, you probably don't want to start right off the bat with methyl B12. The other thing that COMT impacts is your ability to process and excrete estrogens. And so if it's not working correctly, and there are several other polymorphisms that impact this as well, on the first page of the report, some of the cytochrome P450 enzymes, then you can really be predisposed to estrogen dominance. But again, I had a lady a few months ago, she was homozygous for, I think, 3 or 4 Snips that can negatively affect estrogen. But when we checked her levels, they were actually low. So the point being that, you always, when you can, you want to check biomarkers to see what's going on.
Absolutely. And which graph do you like better? Do you like this one over here, or do you like this one better?
Probably the first one.
Okay. Yeah, it doesn't really talk more about the COMT there. All right, that's good. So what are the big nutrients we're trying to give here? Is it that more of just the sulfur amino acids to help more of the COMT brain pathways?
So with the COMT, you got to have all the good minerals. You got to have all the other B vitamin cofactors. Yeah. And so the main thing is just the form of vitamin B12 that you give. You want to, ease into it if you're going to give methyl B12. And, just remember that, you're going to be getting methyl donors from methylfolate, B9. And then if you give B12 in the methylated form, so that's a lot of methyl groups right there. And so that's why, you don't want to give too many methyl groups at once, because not only, it can throw you into a panic attack or anxiety attack. And you can keep, here's a little trick that some people may know, niacin kind of quenches or eats up or degrades excess methyl groups. So if you over-methylate, take too much methylfolate or methyl B12, you can take some niacin to ameliorate the symptoms.
I love it. So let's keep it really simple here. We have 3 major groups here. We have our neurotransmitter kind of synthesis over here, where we have serotonin and dopamine and all the amino acids that flow into that. We have our folate cycle over here. We have MTHFR working. And then we have our methionine cycle, where we're taking methionine, we're converting it to SAMe, to acetyl homocysteine, to cysteine, to glutathione. So we have our glutathione nutrients here. We need zinc, we need magnesium, we need B vitamins, B12 to run our methionine cycle. On the folate side, we need B6, serine, magnesium, B vitamins, folate to run our folate cycle. And then, of course, we need B vitamins and obviously the amino acids, right? Tryptophan, tyrosine, those kind of things to run our neurotransmitter synthesis cycle. Did you want to add anything to that?
No, I think the big picture to take home here. So if you look right here, you see, Krebs cycle, which is our energy cycle.
Over here. Yeah, over here. Yep.
Yeah. And so, energy production is affected by methylation. And so, if you don't walk away with anything else, just know that methylation kind of has its paws or hands in all the different systems of the body in one way, shape, or form. Again, because you're affecting gene expression, which is going to determine, what proteins you create in the cell and which ones you don't. And then, with the ammonia and the citrulline and the nitric oxide, we didn't talk too much about this, but the nitric oxide synthase or synthetase enzymes help convert, they take arginine and oxygen and they make nitric oxide, which is extremely important for vasodilation and blood pressure. So if someone has high ammonia and they're depleting their BH4, they will have trouble creating nitric oxide. The same thing with the nitric oxide synthetase polymorphisms. And then if you look down, we touched on this briefly, but where it says peroxynitrite and superoxide, those are two very strong free radicals. And you'll see past the arrow, it says neuronal damage, and then microglial activation. Your microglial cells are the resident white blood cells in the brain. And we kind of have this habit in medicine of saying that something just has a structural role. And then, a few years later, we're like, okay, maybe it doesn't just have a structural role. Maybe it has a lot of functions. And the microglia are just like that. They're meant to be, are not meant to be turned on for long periods of time. And when they are, you get death of the neurons, the cells in the nervous system. So, it's not just a moot point, it's an important point. And if you have leaky gut, you're going to end up with leaky blood-brain barrier. And a lot of those peroxynitrite superoxide free radicals can, get to the brain and kind of punch holes in the blood-brain barrier.
So it's not just supporting these nutrients, it's about doing things in the right order, correct?
Exactly.
And let's take a look at this genetic test here. The patient sent this in a while back, and I wanted to kind of just go through just some of the key, take homes here. I know that you helped work on this MTHFR support site and create this. So, looking at this, like, what's the take home? You see 2 positives, which mean they're homozygous for these polymorphisms. What does that mean to you on this first page?
So again, like you mentioned earlier, having 2 copies slows that enzyme down more than if you just have 1 copy.
Correct.
And the 1A2 and the 1B1, those can also. So I tend to look at polymorphisms in groups in terms of how can they impact your physiology. And so COMT, along with the cytochrome P1B1 and the 1A2, those can all affect estrogen levels. So grouping those together, one by itself may not have a significant impact or a clinically significant impact.
So kind of these right here, these all together, the C1,
exactly.
all the way down to the B1.
Right. And just so everybody knows, when you see CYP, that's phase 1 detox. So that stands for cytochrome P450.
Ah, good.
And so this is, again, taking, fat-soluble nutrients and making them water-soluble. And you want to, when nutrients go through phase 1, they come out, they're actually more reactive than they were, more dangerous than they were before they went in. That's why it's important to have phase 2 and phase 1 in sync. If you have a phase 1, phase 2 mismatch, you can have a lot of free radicals kind of sitting around and causing damage to a lot of different structural components in the body.
Got it. So if we look at this person, they have a homozygous here for the C1, the CYP1B1 and the CYP2B6 and the, those 2. What does that mean to you? Like, how would you change the program now?
Well, so there's different ones. If you scroll down, I can't do it, but if you can scroll down to where it says 2D6, for example.
2D, keep going.
Yeah, just to where, okay, right there. So where it says 2D6.
They're heterozygous for that.
Right. So the point with this one is 30% of all medications go through that pathway.
The CYP2D6, 30% of meds do.
Yeah. And so now it doesn't mean you can't take that medicine at all, but you need to let your healthcare provider know because, for example, a colleague of mine, her electronic medical records, she does some epigenetics too. She has, like, if she writes a script for a drug and the patient has like a cytochrome P2D6 polymorphism, she gets a warning box coming up. So she has some really advanced software, and that's how it should be done. You can Google the list and see all the meds. It just means that, you're gonna probably need a lower minimally effective dose. Sometimes some of the meds on there, if this CYP2D6 is slow enough, you may not be able to take those medications at all. But going back up to where, you had the 1B1 and the 2C19.
Nine.
That one's also important
B6.
for processing a lot of medications. And so the cytochrome P4 or cytochrome P450, the more Snips you have in this phase 1 pathway, the more I'm likely to recommend, a dual phase optimizer, meaning a supplement that simultaneously supports phase 1 and phase 2.
Got it. Would that be like herbs like milk thistle, silymarin, various like amino acids like taurine and sulfur amino acids too?
Yeah, the taurine, I mean, that's more phase 2, but it can help phase 1. But yeah, and right there, if you look at the last 2 polymorphisms, those are extremely, extremely important. I'm heterozygous for PON1. PON1 has to do with being able to detoxify organophosphate pesticides. And so, you might say, oh, I'm going to eat avoid the dirty dozen and eat the clean 15. Yeah. Well, that's not going to be good enough if you have PON1.
You got to be full organic.
Yeah, exactly. And
the SOD3, what is that one?
That one, superoxide dismutase. So, if glutathione is here, SOD is like right below it in terms of importance.
Yep.
They both sit in front of the mitochondria and protect it. And the mitochondrial DNA doesn't have those histone proteins protecting it. And since it's generating, when it creates ATP, free radicals, it's very important to have enough superoxide dismutase and glutathione. So, certain, vegetables, cruciferous vegetables can help, but there's also, supplements that will, like SODzyme, that will help raise the superoxide dismutase. But the one big take home here is that, I don't recommend anyone take fluoroquinolone antibiotics unless it's a life-threatening situation. And even though they have a black box warning, doctors are still handing them out like candy.
Well, what would be an example of a fluoroquinolone?
So Levaquin, Avelox, Cipro.
Yep, Cipro is a big one.
Yeah, and there's, maybe 2, 3 more, which, I just can't understand why we're using things that are so potent for something so minor. But people with this polymorphism, I've seen them wheelchair bound after being flaxseed.
Wow. Let's keep on moving here and just kind of hit any of the other homozygous ones here that you think are important. Anything here that you want to highlight? The ACE or the ADA or
the ACE, the angiotensin converting enzyme, can play a role in blood pressure, hypertension. It also can cause you to pee out your electrolytes, especially potassium, faster than someone without this polymorphism.
And ADA as well.
ADA, yeah, it can play a similar role. I was looking.
How about the BHMT?
So the BHMTs, that's, if you don't need to bring it back up, but that's the shortcut around the methylation cycle. Normally, the one that I focus on the most is the BHMT.
So right here. So that's the tetramethyl. That's the tetra, or the trimethylglycine to the DMG, to the dimethylglycine. That's the shortcut right here.
Correct. Exactly.
Got it.
And so the most important one, at least from the research, is the BHMT08. It creates a lot of anxiety, and it can further aggravate COMT by causing elevated norepinephrine and epinephrine. So it's common for alcoholics to have at least 1 or 2 copies of that polymorphism. So those people, need to balance their GABA, with their stimulating neurotransmitters. And it's that inner anxiety, sort of turmoil, inability to sit still that drives them to drink. So, that's something that, can be very important.
Anything else you want to highlight down here? Let's just stick with the ones that you think are the most clinically relevant.
So the DAO, up, a few lines, diamine oxidase.
Yep.
Is
histamine enzyme.
Yeah, it's processing histamine in the gut. And, there are enzymes that you can take to help with that process. But you also want to take the 30,000-foot view and say, what's causing the mast cells to release histamine? So viruses can cause it. Elevated norepinephrine can cause it.
Bacterial overgrowth in the gut can cause it, right?
Absolutely. Absolutely. And so, leftovers, eating leftover food, that can cause high histamine. And histamine as a neurotransmitter can cause insomnia. So that's important.
Got it. Anything else you wanted to highlight down here with the DMGDH or the DT?
Nah, I'll stick to the more, I think, relevant ones. So this one right here, the FUT2, it has to do with B12 levels, just like MTRR and MTR. And it basically means you're going to need higher amounts or more significant amounts of B12. But it also has been correlated to lower levels of bifidobacteria in the gut. And Grace Liu from the Gut Institute, she talks about this. It doesn't always pan out that way, obviously. That's why you want to do a stool test, but it certainly can contribute to it.
Got it. Anything here with the GAD?
The GADs are super important.
GABA, right in the brain.
Glutamate, is supposed to be converted to GABA with as long as you have enough B6 or P5, P50 activated B6.
Got it.
And if you have the GAD polymorphism, glutamate and GABA are on a seesaw. If glutamate gets too high, it's going to activate those excitatory cells like the microglia, right? And over time, I mean, short term, it causes brain fog, mental fatigue. Long term, we're talking Alzheimer's, Parkinson's, MS type stuff.
What about this? What about this G6PD? I know we talked about that over in the methylation cycle. Over, where is it? I think it's right here. Yeah.
Let's see where your arrow is.
G6PD.
Yeah. So the G6, PD plays a role in the whole sulfur cycle, and along with SUOX, which 23andMe doesn't check for, to my knowledge, but sulfites and sulfates, and then the G6 PD processing, participates in a number of reactions, but processing red blood cells, making sure hemoglobin levels are optimal. Those are some of the most important things that come to mind when I see the G6PD. One little just quick comment about the GAMT. I know there's only one heterozygous. That one has to do, actually that's the GART, but just in case, so your listeners know, GAMT has to do with creatine. And so, you can find yourself, get your skeletal muscles getting fatigued prematurely. You might have trouble putting on muscle mass. But, if you go to PubMed and you look up all the positive benefits of creatine, it's a mitochondrial energy supporter. So I just wanted to throw that out there.
That's great. Anything else here that you wanted to highlight as we go down the list that you think is really important?
The GSSs. So those are the have to do with the glutathione pathway.
Yep.
And a lot of people, they'll give glutathione, but they may not be good recyclers of glutathione. And so, there's different nutrients you can use to help with the recycling process, because you want it to stay, you want it to donate its electrons, become oxidized, and then get reduced again so that it can help out. Correct. And so, every stressor we encounter, especially environmental chemicals, that depletes your level of glutathione. And then if you're, not making enough, or, your stressors are just too high, you're gonna make yourself more toxic, because the more inflamed you are, the less capable you are of detoxing. And then if you look at the very top there, the GSTM, that's also part of the glutathione pathway. And, when you add those up, you can check RBC glutathione or pyroglutamate on an organic acids test.
Right.
But, at the end of the day, I think, I won't say her name, but, she goes around writing articles saying, oh, you shouldn't take glutathione because it's going to cause substrate inhibition. But you look at the literature and it clearly states that as your levels decrease, your risk of every disorder known to man increases. So I don't know about you, but I'm going to stay with my glutathione.
Yeah. Would you also give some of the precursors as well, like the cysteine or the glutamine or glycine?
Someone asked me this question on the podcast, I think last week or 2 weeks ago, and I don't have an answer as to why. I'm still searching, so you may know. But this happened to me, and it's happened to a number of my patients. I can take glutathione till the cows come home, and I feel great. Even IV pushes. But if I take N-acetylcysteine, I would get a metallic taste in my mouth. And I haven't done it recently, but this is a couple of years ago. I would have a candida flare up. And, I've asked a zillion practitioners and doctors. None of them can tell me why, since it's the precursor to glutathione. But just know that it can happen.
Well, I would think maybe if it's N-acetylcysteine, it could be, that's also a biofilm buster. So it could be maybe liberating some bacteria.
That's a good point. It could be. Absolutely.
Could be. It's possible.
Absolutely.
Are there any here that you want to highlight that you think are really important?
Go down real quick.
Yep.
Or no, sorry, other direction.
Yep.
The HNMTs.
Yep.
Yeah, those guys. So that's histamine and methyltransferase. So that process is histamine systemically. So, we won't talk too much about mast cell disorders, but histamine, we talked about a number of things that can stimulate the production of histamine. But one little nugget that I'll throw out that most people don't know, the histamine is not the main chemical that mast cells release. The main chemical that they release is prostaglandin D2.
Ooh, that's a good one.
Yeah, and you can check it through LabCorp. It causes hair loss and balding. But again, like we mentioned earlier, you want to find out what's stimulating the mast cells.
Got it. So the prostaglandin E2. So that's
D2. Sorry, D is a dog.
Oh, D2. Okay, so that's not the same as the eicosanoid, the E2 pathway. That's different.
Yes, exactly.
Wow, D2. Okay, and that's all right. Interesting. Inflammation has many different effects. That's why we got to get the gut better. Phenomenal. Anything else that you want to highlight before we wrap up here that you think is really important? Like, do you want to look at the MTHFR stuff? Do you know what that would be?
I just point out the MTHFD1.
Yep.
If you scroll back up a little bit.
Yep.
So that means you need more, or you need to supplement with some form of phosphatidylcholine or some form of choline to help support your cell membranes.
Yeah.
Because obviously, if your cells can't communicate, it leads to overall tissue and organ dysfunction.
Egg yolks, right?
Yeah. So, you can do things like sunflower lecithin, etc. But you can go ahead to the next page and we'll wrap up.
And then, do you know where the MTHFR would be hiding? I didn't see it in that first part there as we went through the M's.
No, it might be, they might have moved it. It might be down here further.
Yeah, let me just see if we can do an MTHFR. Yeah, I'm not seeing it come up here.
Oh, if this was a recent test, 23andMe took away 7,000 markers. Oh, there
it is, right there.
Okay.
So here's the 1298C.
Right.
And then here's the 677T. So he's what? Heterozygous on one.
Mm-hmm.
And then on this C1, he's homozygous. I typically don't see this one too frequently. I don't see that one talked about. I don't see that one talked about. Can you?
Yeah, there's not as much research on it from everything I've been able to dig into.
So just these, the 1298C and the C67T.
Those have the most, have been studied the most. Exactly.
So would you worry about this one here as much?
Well, I would look at, one of the methylation action test or, metabolite tests to see what your methylation cycle is doing. Because again, you have heavy metals, you have oxidative stress, all these other variables that contribute. So, you don't want to just rely and say, okay, you're homozygous, so we need to give you way more methylfolate.
Totally. Are there any other markers that you wanted to highlight here that you think are really important, like the last marker you'd want to talk about?
Scroll down. What's on the next page? So the NOS and the PEMTs. The NOSs, again, nitric oxide synthetases. Now, I'm reading a book right now, The Nitric Oxide Solution. And, of course, I knew it was a signaling pathway or system throughout the body, but it's important for immune function, mitochondrial function. It's not just blood pressure and arterial health. And so you can buy nitric oxide testing strips that you hold under your tongue and check your levels. And, do not this goes against what, most bodybuilders think, but you don't want to take L-arginine. And in fact, patients that have had an MI or heart attack, it can actually worsen their condition.
So what would you do to increase nitric oxide naturally?
So what one would be photons from the sun.
Okay.
or a photon machine. Like I have a lumen photon machine.
Cool.
And that, increases nitric oxide. And then there's a product called Neo 40 that it doesn't have L-arginine in it, and it helps to build up your levels. So that's how you go about it. And again, I'm sure there's a lab test that I don't know about where you can check the different types of nitric oxide, because there's INOS, ENOS,
Yep.
NOS.
Yeah.
And some are beneficial, some are not. But the point
The
being,
I is immune, the E is endothelial, that's in the bloodstream, and then the N's more neurological in the brain, right?
right, exactly. And so it's a sort of a Goldilocks phenomenon. You don't want to go too high with the nitric oxide, because that can stimulate different viral pathogens and deplete lysine. But the other thing I'll point out there is the PEMT. It kind of goes with that MTHFD1 from above, meaning that you're going to require some choline from some source. And that's just super important, because just like you and I are having a chat right now, if our cells are sitting next to each other and the cell membranes aren't healthy, they can't talk, and that's going to have ramifications in every system of the body.
Love it, Dr. Tim. Are there any other genes you want to mention that we didn't get a chance to go through in that 62-page PDF? Anything else you wanted to highlight?
There's one called NQO1 that has to do with antioxidant function and, in some instances, mitochondrial health.
NQO1?
Yeah.
If I can find it. Man, that's an abstract one.
Look for the article on self-hacked.
NQO1. Yeah, it's not in this document. Okay. I must have missed it. I mean, 62-page PDF of genomes, and nothing's there on that. Okay.
Yeah.
Any other ones?
No, I mean, yes, but I think that gives them a lot to digest right there.
Went over a lot of stuff, man. And again, if someone's looking at this and is really overwhelmed and needs some help from Dr. Tim to break some of this stuff down or go over their genetic test, Dr. Tim's a phenomenal reference, and you can get a hold of him at healyourbody.org. He'll have a new site coming soon, which is great. Are there any other good resources you recommend to get some of these genetic markers kind of dialed in, get a better grasp on them?
I keep a physician friend of mine just emailed me a new company that came out. A lot of these companies are kind of just taking a certain set of Snips and they're giving like diet recommendations, exercise recommendations, more aerobic, more anaerobic. So, a lot of those are coming out.
Any thoughts of that new Viome gut test?
I'm actually an ambassador for them, and I have my box sitting right over here. So,
I was at a conference this last weekend in Vegas, and I ran into Dr. Stephen Barry, who started Metametrics Lab decades ago. I'm sorry, Genova Lab decades ago, and he's kind of the big ambassador on the Viome test. So what do you think about it? I know it's looking at more of the RNA, where the Ubiome was looking more at the DNA aspect. What are your thoughts?
Yeah, well, so it's kind of the same thing we just went over. We're looking at what's expressing, what metabolites are being produced. So we just looked at genetic polymorphisms, and we could look at an organic acids test to see what Snips or genetic Snips are expressing. But the Viome test, I'm excited to do it. It looks promising, but I haven't seen the report or anything yet. I got to send in my sample. But it definitely looks like a next generation type testing.
Now, from what I talked about, I had a conversation with Barry over the weekend. He said that it's going to give you food recommendations to alter your microbiome. It'll tell you a lot about infections. They're not making any recommendations regarding botanicals or herbs or antibiotics to knock out infections, only food. So it'll be really interesting to see, as functional medicine docs, we may prescribe various herbal medicines to knock these critters out. The lab's not really getting involved in that.
Yeah, it includes a glucose tolerance test as well.
Oh, cool. And that's by Naveed Jade, right? He's that multi-billion-dollar guy.
Yeah, I emailing back and forth with him. I had no idea who he was. And I'm like,
I met him last weekend, man. I met him. Really nice guy, super smart. He's a massive disruptor.
Can you say what conference it was?
Yeah, it was the 10X Growth Con by Grant Cardone.
Oh, Grant Cardone, yeah.
Yeah, we're hanging out. It was great.
Awesome.
Cool. Anything else you want to add, Dr. Tim?
I think that's it.
Hey, man, I really appreciate your knowledge bombs. I want to get you back on here soon. If you guys are liking this, give me a share, give me a thumbs up. Head over to Dr. Tim's site, healyourbody.org.
Yeah, let us know what type of information you want to hear, and we can tailor it to that.
Yeah, so give us some comments on this post. We'll comment down below or respond to it. Dr. Tim can check out the video as well. And everyone, hey, appreciate everyone tuning in. Dr. Tim, thank you so much for your time and effort and your serious knowledge bombs.
Thank you for having me. I appreciate it.
Thanks a lot. Hey, you take care.
All right.
Bye.
Bye.